Welcome. Let's see the generation and detection of QPSK signal in this lecture. So the QPSK signal is represented by this. Si of t is equal to Si1 phi1 of t, Si2 phi2 of t. This is the in-phase channel and this is quarterly phase channel, and you have seen this signal space characteristics of QPSK in the last lecture. And phi1 is this, phi2 is this. To generate a QPSK signal, what you need to do is you need to find Si1, multiply by phi1, find Si2, multiply by phi2, and add them together. So you have 4 symbols to transmit. Corresponding to each symbol, you need to find Si1 and Si2 and then multiply by the corresponding bases and add them together. Okay. So for that, we have seen that there is a one-to-one correspondence between this bit position and this signal vector element and this bit position and this signal vector element. So what we need to do is, if I have a 1 here, I have a plus root t by 2 here, and if I have a 0 here, I have a minus root t by 2 here. If I have 1 here, then I will have a plus root t by 2 here. So this is Si1 and this is Si2. Then multiply this with phi1, this with phi1, and this with phi2, and add them together to form the QPSK signal. So the first part of the generation will be a polar non-return to 0 encoder. That is, I have a binary sequence, okay, binary stream coming in. So you take, say this is a binary sequence. So you just take this as B1 and this as B0, and in this next bits take this as B1 and this is B0, like that. So you need to separate B0 and B1, okay, and multiply each with its basis and generate this QPSK signal. So you have the bit streams here. First you need to convert that into either plus root t by 2 or minus root t by 2. That is, so you take a bit. If you have a 0 here, that should be represented by minus root t by 2, and 1 here, that should be represented by plus root t by 2. So that's what we do first. So you have the bit stream coming in. So if you get a 0 here, you will generate a minus root t by 2 here, and if you get 1 here, you will generate a plus root t by 2 here. And in the demultiplexer, you know what is a demultiplexer doing? It has one input and many outputs. It is simply a branching, okay, it's simply doing a branching. So the B0, the first bit, okay, B0 bit will be branched to this branch, and the B1 bit will be routed through this branch. Okay, so you will be getting bits here, okay, bits here that is converted to either two voltage levels, plus or root EB. Now if the incoming bit was B0th bit, then that will be branched to this, and if it was B1 bit, it will be routed through this branch, and then you just need to multiply it with basis and then add in the final level. Okay, so what you are doing is, so you have the bits coming in, so take the first bit. So bits are coming in series, right? So you will get this bit first, then the other bit. Okay, so when you get this bit, you will branch that to the B0 bit position here. When you get this bit, you will branch that to this position, and then you will simply multiply it with the basis function and finally add to generate the QPSK signal. To detect the QPSK signal, you know, you have two independent BPSK channels. This corresponds to phi1 and another BPSK channel which corresponds to phi2. Okay, so you know how to detect a BPSK signal. So you just need to decide the observed signal value is greater than 1 or less than 1. If it is greater than 1, it will be detected as 1. If it is less than 1, it will be detected as 0. So for that, what you need to do is, you have the received signal here, correlate with corresponding bases. So this is phi 1 channel and this is phi 2 channel. Okay, so you will get x1 here and x2 here. This is an independent BPSK channel. So once you get into this position, you simply need to decide, okay, by comparing to the threshold 0. If it is, this value is less than 0, decide it as 0. If this value is greater than 0, decide that as 1. If it is equal to 0, you can do a random decision. Similarly here as well. So you will be getting a bit stream here and bit stream here. This bit stream corresponds to B1 and this bit stream corresponds to the lower bit B0. Now you have a multiplexer here. What multiplexer do? Multiplexer have many inputs and one output. You have 2 bit streams here. It will simply convert that into a single bit stream. You will first, so suppose you need a bit stream like this, B0, B1 like this. Okay, then what it will do, it will first route B0 to the output. Then after one bit duration, it will route this to the output, and again this to this like that. Then you will get B0, B1, B0, B1 bit stream. Thank you.